start out Unit 5, we're going to take a look at monomials. So in this lesson of notes, we're going to be able to identify what a monomial is and then find the product of two or more monomials. Now that prefix mono means one or a single thing. So a monomial is a number, variable, or product of a number and one or more variables with positive whole number exponents. And because it is a monomial, it's basically what that means is it is an expression made up of one thing, one term of things that are being multiplied together. So for example, here's a list of some monomials. 3 is a monomial, x, 6x, 4x cubed, 7x squared, yz to the 6th. See, they can get sort of complicated, but the point is these are all a single term. The only operation going on inside of them is possibly multiplication. So here are some examples of non-monomials. We have x plus 3, not a monomial because of the addition here. 4x minus y, also not a monomial because of the subtraction. 5x over y, we need positive whole number exponents, and this y would technically have an exponent of -1. So you don't want to have variables in your denominator. It's okay if you have numbers, like if this was 5x over 2, that'd be okay, but not a variable. And then 7x to the -4, again, you want positive exponents, so that's a no good either. And lastly, a constant is what we call a number without a variable. So just 3 by itself, for example, that is a constant. Because since there's no variable there, it can't change. So it stays constant. So an example of a constant is 3. All right, so let's really quick determine whether each of these expressions is a monomial, constant, or neither. So this 6x plus 4, well, that's neither because it's not a monomial because it's two terms, and therefore not a constant because it's more than one thing. So this is neither here. 3. Now this is again a monomial, and it is in fact a constant. It's the same example from above, just a number without a variable. So it is also a monomial, but more specifically, it is a constant. Okay, 3/4 x squared. This is a monomial. Because even though we have a denominator, it's a whole number down there, so that's okay. Just a number, that's fine. (9x to the -2). Well, this looks like it might be a monomial, but because of this negative exponent, it's neither. It's not a monomial, definitely not a constant because it has an x on it. 5x squared y to the 6th. Well, this is fine. Just like this one up here, this is a monomial, which again just means a single term that is made up of a number, variable, or product of a number and one or more variables that have positive whole number exponents. So that's the quick version of how to identify what is a monomial. And the last thing on these notes is multiplying some monomials together. So these follow a specific rule called the product of powers rule. And when you multiply powers with the same base, we just add the exponents. And we multiply coefficients normally. So for example, x to the a times x to the b, just add these exponents together, and it's x to the a plus b. So keep the base the same and just add the exponents. Now if you have coefficients, like this, 2g cubed times 3g squared. Well, 2 and 3 get multiplied together to make 6. And then the exponents get added together. 3 plus 2, that's 5. So make sure when you look at monomials being multiplied together, you can multiply the coefficients together, but the exponents get added. And the reason that is true, the reason that happens, if we break this up, this example here, 2g cubed, that's 2 times 3g's. 2 times g times g times g. Times the 3g squared is a 3, and then 2g's. Okay, now to multiply all that together, 2 times 3, that's 6. And then we've got 1, 2, 3, 4, 5 g's, and that's g to the 5th. So that's why you multiply the coefficients, but you just add the exponents, because it's sort of a shortcut just telling you how many of that variable we have. So let's practice. We're going to simplify here. S to the 7 times S to the 5th. Well, 7 plus 5, that's S to the 12th. H times H to the 8th. And remember, if there's an H, there has to be a 1, because if it was 0, there wouldn't be an H at all. So H is just H to the 1st. And then 1 plus 8, that's H to the 9th. And if you're ever not sure, you can just think about how H is just H, and then H to the 8th is 8 H's. So all total, you've got 9 H's there. And that's really what's happening when you're multiplying these together. You're really just counting up how many of that variable there are. Example C, we've got 1x here, 4x's here, and 6x's here. So all together, that's 11 x's, x to the 11th. 1 plus 4 plus 6. Similar here, x to the 5th times x squared. Add them up. 5 plus 2 is 7, x to the 7th. Now on E, don't get confused. Keep the base the same. Pretend it's an x or a m or whatever. So 2 cubed times 2 squared, that's going to be 2 to the 5th. 3 plus 2 is 5. Because it's a number, we can't evaluate that. 2 to the 5th is 2 times itself 5 times. So 2 times 2 times 2 times, okay, let's start that over. 2 times 2 times 2 times 2 times 2, that's 32. So just make sure you get the right number in there. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2, 32. A common mistake here is to also multiply these together and get 4 to the 5th, which, as you can imagine, is a much bigger number. So be careful. Let's keep going. Here are some maybe trickier ones, but remember, multiply coefficients together, add the exponents. So negative 7 times 4, first of all, that's negative 28. And then just go through every variable and add them up. So for the C's, we've got 3 here, and 1 here. So 3 plus 1, that is 4. And for the D's, we've got a 4 here and 3 here. So 4 plus 3, that is 7. Just go one at a time through the expressions, multiply the coefficients, add the exponents. On G, 4 times 3, that's 12. And for X's, I just see 1x. Same for Y. And for D, we've got a D to the 3rd, and that's it for there. Now you could, if you want to worry about proper notation, you could make sure these are in alphabetical order like this, 12d cubed xy. But I'm not going to be too picky. Either one of these will be fine for me. For a more specific assignment, make sure they're in alphabetical order. But these are the same thing. Okay, for H, negative 3/4 w all squared. Let's think about what squared means. That means we have a negative 3/4 w times itself times another negative 3/4 w. And this will follow the same rules as above. So negative 3/4 times negative 3/4 is positive 9 over 16. And w times w, well, that's w squared. There are 2 w's there. So 9/16 w squared. Reduce that if you can, but we can't, so we're just going to leave it like that. Okay, example I. 3y times negative y times y cubed. In this case, these parentheses don't really do anything, since it's all being multiplied. So 3 times negative 1 times 1 is negative 3. And then count up the y's. You got 1 here, 3 here. So 3 plus 1 is 5. So negative 3y to the 5th. On example J here, we've got another exponent. So negative 3r squared times itself 3 times. Just like that. We can break that up. So now just go through multiply. Negative 3 times negative 3 times negative 3 is negative 27. 3 times 3 is 9, times 3 is 27. Negative times a negative is a positive, times a negative is another negative. And then just add up the r's. We got 2, 2, and 2. That's r to the 6th. 2 plus 2 plus 2. So negative 27, r to the 6th. K here is similar to E from above. Keep the base the same. Here the base is negative 3. Then we add these up. 4 plus 2 is 6 minus 5, or 6 plus negative 5 is 1. So negative 3 to the first power is just negative 3. So there you have it. General rule there, the basics of it. Multiply coefficients, add the exponents.